Okay, the video's on. But it should appear right here, right? Oh, there it goes. Okay, yeah, it seems to be working.
Perfect.
Cool. Okay, thanks, Fabio. We'll give you a call back if we need anything else, and we'll talk to Seth as well. Okay. Are we what? Yeah, it looks like it's live. Do you want to log in and check first? Oh yeah, that's what I mean. Yeah, just pop onto YouTube and see if it works. But it's okay, cool. Is the roof good?
Yeah.
Yeah, we're good on the roof. It did get stuck, but Danielle fixed it.
And then you move that one around?
Yeah. Danielle's just about to do it. Yeah, he's doing that. Okay. He says you need to move it more than that.
How much?
10 to 20 degrees RA and deck, both. Go up on deck.
You got stuck.
Huh?
You got stuck.
It got stuck. Okay, cool. Wait, so it's stuck. Do you know what you're doing?
I like last time I got stuck, I had to reset everything. So if he has a better solution.
Okay, he says last time it got stuck, he had to reset everything, so he might have to restart the computer unless you have a suggestion. Yeah, he was hand slewing it and it got stuck. Let me see if I can put you on speakerphone. What is the speakerphone button? Yeah, there you go.
Hey, Danielle, can you hear me?
Yes.
Good. So, did Artemis get stuck
technical
tonight?
Give us just a few minutes.
I mean, I was just moving it around and it got stuck. This is the first time it gets stuck.
No, but wait a second. Did this happen to you tonight or another night?
Just now.
Just now.
Just now. Okay, so it did get stuck, and then you had to. Okay, so if it happens again, and you were trying to slew normally.
Yeah. Yeah, I was.
Okay, so if you hold on, let me turn off the. There's this lag on YouTube that is maddening.
Yeah, it is.
Okay, so my suggestion, Danielle, all you need to do is when you decide to go to an object, okay, try and go with the paddle first around where the object is, and then do the slew command from the computer.
But how do we get it unstuck right now?
Oh, is it beeping?
Yes.
Okay, so is the computer on?
Yes.
Good. Okay, so and SkyX is still on?
SkyX is on.
Yes, good. Okay, so all you need to do is go to the base of the telescope. Just walk towards the telescope, and on the south side of the telescope, near the base.
That's where I see a beeping light there.
Yes. But I don't see you at the telescope. Where are you?
I'm over there.
Aaron is at the telescope.
What?
Aaron is.
Oh, okay.
Yeah.
Okay, so Aaron, just look at the. Hi. So look at the bottom. Oh, right. There's a little light. Not at the very bottom, no. Just, yeah. You know there's a little light near that switch. Okay? In that panel,
Okay.
there should be, there's a little toggle switch. A little silver toggle switch. You see it? Near the light. In the electronics panel there.
Yeah.
Okay,
Okay.
found it.
Flick that switch and leave it off for 5 seconds.
Okay.
Did you flip it?
Yes.
Waiting for 5 seconds.
Okay.
Did it stop beeping?
Yes.
Good. Okay, now hold on. Okay, now go ahead and turn it back on.
Right.
Okay, it's not beeping now.
It's not beeping.
Okay, so now if you can go and move the telescope only in declination, only up in one swift movement of about 30 degrees. Can you do that? No, not that one. It's the other one. It's the other one.
He's on the line.
Yeah.
So yeah, it's up.
Okay, so move the telescope up north. Okay. So the joystick has to go down in order to go up on the telescope.
It's not moving.
Or it might be moving, but slowly.
Wait a second. Is it beeping again?
No.
Oh, it's not moving?
No, yeah, it was just in slow. It was in slow speed.
Turn that knob all the way to the right so that it's on number 4.
Yeah.
Okay.
Yeah.
Now do one swift motion. Keep moving for a little bit on declination. Okay, good. Now you can start. That's fine. Okay. Now, only in right ascension, move west for about 30 degrees.
West is that way, right?
Yeah.
So that's a bit.
No.
Right
That
ascension.
one is not inverted. So I think it's that way.
Okay.
Oh no, it is inverted.
Yes, it doesn't matter. Just choose a direction and go 30
Okay.
degrees in one swift move. Don't stop it. Don't stop it. Keep going. Keep going. Is the telescope shaking?
No,
No.
we're good.
Okay.
Good.
We did it.
Okay. Is it beeping?
No.
No. Okay, good. So now go ahead and bring it back to the meridian in right ascension again.
Manually, right?
Yeah, manually.
Yeah.
Keep going, keep going, keep going. Yeah, good. Awesome. Perfect. Okay, go ahead and stop and then now move the telescope. Try slewing the telescope with your normal inputs from the computer.
Okay.
Try going to a target that is close to where the telescope is pointing now. So you're not doing a very, very long slew.
I mean, choose NF.
Yeah. Huh?
NF.
Which one?
That one.
This one?
Yeah.
Oops.
Lubricate that telescope.
There we go.
Is it working?
It is working.
It is working, yeah.
Okay, did you get it to point actually somewhere? Okay.
It's pointed at
Good.
something we can't
Try.
see because it's dark.
Okay.
Or I mean, smoky.
Still working?
Yeah.
Yep. Shall I do a short one? How about this one?
Okay, so try and avoid long slews. Just try and step it. So if you have to go across the sky, do short hops.
Okie
So
dokie.
just, click on a portion of sky in between where you want to go.
All right, Fabio.
Sounds good.
It's
Okay,
working.
it looks like it's working good. So
Yeah.
I think so. Thanks
we're
for your
in
help.
good shape.
All right, thank you.
Okay, ciao. You're welcome. Bye-bye.
Bye.
All right. So
That was so weird because there was a delay.
yeah, there's a big lag. Is that normal? Was that happened last time?
The delay in the video, yeah,
it's probably Zoom, right?
or maybe it's not live or something. I don't know.
I think it is live. I think it's probably Zoom like retransmission.
It's
or
probably the
something.
Zoom to YouTube connection, yeah. But here we are at the telescope, freezing. Cool.
Okay, and how do you make it so that they see this?
What?
Like, how do you make it so that they see?
Oh, we can screen share to do this guy. God. Okay, I don't know who's watching. It says we have 3 viewers. I don't know how many of you are staff just checking on us and how many of you are not, but we're going to try and share the screen so you can see our beautiful sky map. And we have, what is going on here?
Hello, guys.
Share that. There's some other window here. Thanks for trying to open 2 of them, so let's not do that. Okay, I think we're still good. No, okay.
Oh, there you go.
Oh, we're doing the screen share.
infinite
Okay.
delay.
Yeah, there is a very long delay.
Yeah.
So should we leave the lights on? I don't know. Last time we had the red lights on, but since we're just looking at the sky and nobody's here, I guess we don't need red lights.
I guess it feels weird.
To have the lights on?
Yeah.
Well, yeah, but they can see us this way.
Hello. Do you guys want to see us?
I don't know who's gonna answer. Hold on, let me just turn on these red ones. And then we'll see how it looks.
I remember being able, like,
It's pretty dark.
hey,
They can't see us at all.
damn, that's what was that one?
That light is out, and so is. Oh wait.
What are this? Ah.
Are the floods red or are those white? Oh yeah, we have that one too. Nice. Okay. Oh yeah,
We're working the light in here.
that's good. This is some effective astronomy lighting. I like this. Although it is kind of in my face, but we'll just have to deal with that. Should I even bother with my glasses? I don't think so. Well, we're getting a call. Hold on 1 second.
Sommers Bausch. Okay, good. Yeah, the ones are, we have those. Well,
What?
the ones on the back aren't on. Is that what you mean? The ones in front of us on the wall are on.
I think it's the boss again.
What do you mean the ones on the back?
You go in, you know, just at the door, at the entrance, there is a rheostated knob inside the door.
Inside the door. What is it?
Yeah.
Yeah, just go ahead and turn that on.
Turn it on. On.
Perfect. Good.
What?
Yeah, now I can see that there's lights on.
There was on the back wall.
Oh, the back wall lights. Okay,
Yeah,
yeah,
yeah.
thanks for that.
Yeah, so it turns on the back wall, and those are the floor lights, so it gives a little bit more light, and it's all red.
It's looking good.
Yeah.
Anything else?
No, that's great. I think you guys are doing great.
Okay, cool. Thanks. I don't know who's on the
Thank
stream,
you.
but we'll find out.
Okay. Bye.
Bye-bye. Oh, gosh. Where's my receiver? Okay, I think we're ready.
So we're ready.
And now we can actually see the clouds and where to not point the telescope. I did tell some of my friends to log on, but I don't know if they got the message.
I told some people to log on as well.
Nice. Okay. Well.
Algunos no hablan inglés, so that's why I'm trying to shut in.
Hmm?
I told some friends that
Oh,
there's a lot of them that don't speak.
Oh yeah. It takes me a second to process Spanish because it's been so long since I used it regularly. What is this? This Zoom bar is like right here. Okay, we can just move it over there.
Yeah, okay.
There we go. Okay, I think we've got everything sorted out now. So what shall we look at tonight? What can we
Well, it seems like Mars is out. You want to do Mars?
Yeah. We can look
course.
at Mars. Sure. I was gonna say we could attempt to do this in Spanish, but I probably won't know what's going on half the time. Well, we could do it in both because we probably have English viewers too.
Well, I don't know if there are Spanish viewers. So.
Oh, fair enough. Well, if anybody's watching and wants to use the chat to tell us if you prefer English or Spanish, or if you can do both, feel free to chime in and we can maybe do this as a bilingual session tonight.
Sí, hay alguien que no habla inglés o viendo esto ahorita. No, we have to wait half an hour for this.
Yeah, because of the delay. Yeah. My problem is I have forgotten many words, so I have to like search for them in my brain. I didn't slew to Mars yet. Oh, that's right. He said to step slowly, so let's
go to that one.
Step slowly over to Mars. Is it up high enough? It should be. It's in a big cloud bank, though. Yeah.
I don't see it.
We're not going to see no Mars right now.
What are we going to see, actually?
Well, the moon was up for a minute.
So the weather is not the best today.
Yeah, it's been...
It was clear like 20 minutes ago. Well, kind of.
Yeah. So, I don't know who's on or where you're living at, but here it is below freezing, which is why we are all bundled up. I have my ski jacket on. And it was pretty cloudy all day, but right when I got here, the sky was perfectly clear. And I was like, oh my gosh, we're going to get to see things. But now the sky is... Oh, wait, Mars came out.
No.
Quick.
Yes.
This is Mars. Kind of how it
quick,
ends up being.
I risk it. I will risk it. Just go to Mars.
No, it's going to be okay. The next slew is going to be fine. We're having to move the telescope slowly, one like little step at a time because of it's so cold. It was having some issues. Oh no!
No, okay. It was still slowing.
Oh, okay, cool.
Yeah.
Slew one more time.
There you go.
It looks terrible to me, but my glasses aren't on. No, it looks okay. Okay. Now, what do we do with this again? To take a picture. To take a picture with the camera. Let's see. That's probably too long of an exposure.
So yeah, sorry for taking so long. Oh, yeah. There you go.
We'll get there. We'll go a little late, maybe.
We have someone on the chat.
We have someone on the chat. Hey, it's my cousin. Hello. How did you find out? Did my dad text you this information?
I have to wait for this.
Oh yeah. So every time we say something or do something, there's like a slight delay in YouTube compared to Zoom. Yeah. Okay. Dad sent them the link. Nice.
Okay. Yeah. It's there's some lag, but it's less.
That's okay. Yeah.
Less than 9. Yeah.
So we're gonna try and take it. Mars just went behind the cloud.
I knew it. Well, let's wait.
Okay, we can look at the moon, but it's all the way over there. So
you have to take steps and then.
Yeah. Well, let's see. Where's the moon? This should be over here, somewhere in this quadrant. I'm hoping people can see my mouse. Since we're connected to YouTube, I don't really know how it works.
I mean, they can look.
Yeah, I can see it there. Okay. So where is moon? All those are under the horizon almost. Or not the horizon, but the telescope horizon.
Yeah.
Why is it so hard to find the moon? The moon is huge.
I will always just bite the dust and just go like.
Moon. Oh yeah, we can just do. So another thing we can do in this lovely program, instead of clicking around on the map, we can just type in our target name if we want to. That's not it. I'm trying to type with gloves on, and it's not easy.
There you go.
Moon.
That's the one.
Center.
There it is.
Oh, why is it so dim? That's weird. Okay, we're gonna go ahead and that's a long slew. Okay, I just know where it is now. So we're gonna do a short slew to. Ooh, we can go to Neptune.
Yeah, we should. Well, I mean, you won't be able to do anything.
Yeah, I mean, we're not gonna see Neptune. I think it's way too dim for even if the conditions were good. I don't think we would be able to do it. Let me see. Yeah, so here's how I tend to evaluate whether I can see a target or not. In this window here on the left, we have some like astronomer's stats for different objects. Honestly, most of these I ignore because I'm a planetary scientist, so I don't know what I even mean. But the important one here is magnitude. And this is sort of a weird way that we measure brightness. And the scale is kind of bizarre because you can have negative magnitudes, and those are very bright objects, and positive magnitudes. And the bigger the number and the more positive, or like the bigger the positive number, the dimmer it is. It's kind of counterintuitive. But typically with these telescopes, which are 20-inch modified Dahl-Kirkham telescopes, if that means anything to anyone.
I thought the word Cassie Green.
I'm pretty sure they're Dahl-Kirkham. I remember that from when I started because it was a really weird name that I never heard of.
I think yeah, maybe
Either way.
Yeah.
So these particular telescopes, which are about 20 inches, which is maybe like this big at the end of it, can get down to maybe 6th magnitude. Hey, it's Fabio. He's online.
Hey,
All right.
Okay, Fabio.
Fabio, the boss is here.
What's the type of telescope?
Yeah. I think it's Dahl-Kirkham or modified Dahl-Kirkham or something like that. But Danielle's remembering.
I think you're right.
Casgrain?
I think like I just said. They explained to me what that was, and I was like, that's just because I said like that's just.
Yeah, it's not that different.
Yeah,
but it has like a special name. Anyway,
Yeah,
the point is we can get down to about a magnitude of 6. So that means anything higher than 6, we actually cannot really see here. That's been my experience here. On a really good night, you might get something a little dimmer. But especially being in the middle of Boulder and 20 minutes from Denver.
The moon is okay, Mars. Go to Mars.
Okay, we're already on Mars. Great. Let's take a picture.
We're in Neptune.
Oh shoot.
No, you did it too. You're in. We're on Mars. Take a picture.
We're on Mars. Okay, we're gonna take a picture of Mars because we wasted so much time talking about magnitudes. We can just take a picture. Okay, take photo. We're gonna have to play with the settings to see if this is a good exposure. That's a terrible exposure. Oh, you know what, you guys. No, we gotta fix it because I'm only sharing the SkyX. I'm not sharing the photos. Why is it doing this? Why is it taking so many
Because
photos?
you're focusing. So it's taking every 0.5 seconds.
Oh, whoops! I meant to be on this tab.
So abort.
Abort. All right, let's try that again. But first, I need to redo the screen share. So bear with me for just a second. I will share the entire monitor.
Yeah,
oh wait, maybe it was just doing the whole monitor.
No, you were right. Oh no, you.
Yeah, screen 1. Yeah, okay. Yeah. Sorry, it was fine. I just misunderstood what was happening. Okay, you can actually see the whole monitor. So let's corrected Dahl-Kirkham. That's what it is. Okay. So let's try this again with the photo. 5 wasn't good, so I'm going to go down to 0.1 seconds exposure time and see how that looks. And it's just still there, barely. That's still pretty darn bright. So planets are very bright because they're quite close to us, not because they are intrinsically emitting lots of light. So let's try 0.0.
Do the minimum and see if the
minimum. What's the minimum?
0.001.
Really?
Yeah.
This might be.
Let's see.
Let's see what it does. Oh yeah, it's still far too bright. Let's see. Where's
here's the count. And the maximum is 60. Yeah, it's saturated. So put a right filter.
Where's the view where we can get the plot on the bottom now?
No.
Thank you. Yes, there we go. But this is in log space, it looks like. So yeah, so the problem here is that Mars has saturated the detector, so there's just too much light coming in for the exposure length. So we can't really see much.
So put a filter.
Yeah, so let's do my God, it's cold. I'm sorry. Okay. Yeah, thank you. It's too cold to think.
Oh, we already have filter.
Oh, that was already on the red filter. Okay. Ooh, let's look at the H corona. Yeah. Well, this might not actually do it, but we can try it.
What do you mean? What's the H corona?
There's a big cloud of H around Mars. I don't think this is actually gonna get it.
Yeah,
But
Fabio is like
Fabio thinks we're hilarious.
no, but also like I don't know what joke he's laughing at because I don't know how bad is the lag.
Probably. Oh yeah, I don't know.
Yeah.
Probably at our complete ineptitude and how cold it is. Okay, what was I trying to do? I did a filter wheel and we're trying to take a picture.
Take
Okay.
a picture now.
It's still visible.
Of the age of a corona. What's the age of a corona?
Oh, it's a little better. Now it's disc-like, so that's cool.
Yeah, now yeah.
But you cannot really see what I'm talking about. But last time I was here, we took a picture with the O3 filter, and I don't know what the O3 filter, like what the actual wavelength range is or what it's actually doing, but it looked like we were able to see sort of an asymmetry that might have been an oxygen corona, if we're very lucky. So let's try it. Nah.
Well, I mean,
Pretty symmetrical.
It's a better picture. It's a better picture though. Maybe
Yeah.
like look at the pixel values. Maybe it isn't symmetrical.
No, it's still saturated.
Yeah, I don't know.
Oh, great. My whole family. I never should have texted my dad. Oh, God. All right. That's okay. Nobody can tell me to do anything because I have control of the live stream. Ha ha ha. Okay. Well, so that's not that great, but there's Mars. It's a disk. It's not a point. Well, a star is not a point either, but they look like points, kind of. The moon is looking pretty good.
Is this the
Do
best
we have
thing
a?
we're gonna get? Yeah.
Yeah, we can mess with the. We can definitely mess with it to do that.
But you don't really. It's not like you can see features.
No,
Mars,
the
right?
last time I was here, I think we almost got to see like I said, the asymmetry where we might have been looking at the oxygen corona, which does exist. But we're not going to see too much today, especially.
Okay, so
but the moon is looking all right. Do we have a moon filter we can do?
Wait.
What?
Talk us about Mars.
About Mars?
Yeah.
What do you want to know about Mars?
Is there an atmosphere?
There is an atmosphere on Mars. Yes. So what I was referring to.
Okay,
He's doing a cheat sheet on the other monitor.
Yeah. Okay.
But he's looking at images. Yeah. So Mars does have an atmosphere, just like Earth, except a lot thinner.
Picture?
Yeah, there's some pictures of the atmosphere.
This is an actual picture?
There.
This is a picture? Okay, there you go.
Yeah, what is this? This is the green glow. This, I should really know what this is, but I.
This looks like a city. Okay.
It is not. It's probably part of the polar cap or something. I'm not as familiar with this specific image. And I don't remember the details of this news release. I don't think this is exactly an aurora. We do see aurora at Mars, actually. There are about 3 different types of aurora. And they are not quite the same as the aurora on Earth, but they are similar in that they have sort of similar sources or reasons that they occur, but they don't quite look the same, and you wouldn't see a brilliant light display on Mars like you would on Earth.
So there's a magnetic field on Mars?
Yes and no. So the Earth is sort of unique in that it has this strong magnetic field. You know, we have like the North Pole and the South Pole. That's why compasses work. But Mars doesn't really have that. So the reason Earth has that, to my knowledge, as not a geologist, is that you've got this liquefied core in there that's in the center of the Earth that's sort of generating this field. But Mars does not have this same kind of core. So it is not generating a strong planetary magnetic field. But what you do get on Mars are what we call crustal fields. And I could probably bring up a little picture of that for you here in Google. I'm gonna take off my gloves to do it.
What's crustal? What? Sorry.
I will show you. It will make a little more sense.
Okay.
Actually, let me first show you the Earth magnetic field, sort of a cartoon of that. So yeah, so here's just a simple cartoon. There's a North Pole and a South Pole, just like a little bar magnet that you might have at home and could play with. And these magnetic field lines go from one pole to the other pole. So that means if you get like a charged particle, like an electron, it'll follow the field line in that pathway. So this is the Earth cartoon. Keep this in mind. It looks kind of like lobes or something. But when we look at Mars, we see a very different picture. Oh, I'm sorry. These are all scientific plots. Let me find a cartoon.
That one, I mean, I guess this is a comparison.
No, yeah, sort of. That's not the one I was looking for here. So the thing to do when you want to see the right kind of like scientific cartoon is you got to Google the
Wikipedia.
person. Well, no,
Okay.
the person that you know makes it. So I know that Dave Brain knows all about this. So we'll see what pictures appear if I Google Dave
No,
Brain.
he freaking took a picture of his notebook.
No, this is actually
Dave Brain.
no, this is drawn by this guy, James Tuttle Keene, who is really awesome. And he goes
Okay.
to conferences and he draws people's results while they are giving talks. And he's really good at drawing, and it's pretty cool.
That's very quick.
Yes. Okay, but a digression. So this is what I was looking for. This is a better explanation. So instead of just those smooth lines going from the North Pole to the South Pole, you have basically a bunch of hairy magnetic lines just sort of going all over the planet. So what you see here in this picture, the red lines are what we call closed field lines. So they're sort of like the ones going from the South to the North Pole, but here on Mars, they just go from like one spot to another random spot on the surface. And then the blue field lines are what we call open field lines, which basically just means if a particle was to get along one of those lines, it would just shoot away from Mars, or maybe toward if it's facing toward. And if the particles are sort of following these closed magnetic field lines, which are the red ones, then they'll sort of just tend to stay near the planet. Of course, this is a big oversimplification, and there's a lot of ongoing research right now in Dave Brain's group, actually, trying to figure out, do these magnetic fields like help trap the atmosphere on the planet and keep it there, which is good because like atmospheres are important for life. So, you know, on Earth, we take advantage of that. Or are these field lines actually helping the atmosphere to escape and having Mars lose the atmosphere? So we don't really know the answer. It's probably a little bit of both.
So Dave Brain is a professor here at CU Boulder.
Yeah, sorry, I didn't say it, but
Yeah.
he is a wonderful human, and he knows all about magnetic fields on Mars. So if you ever want to know about magnetic fields on Mars, just write him an email. I'm sure he won't mind. Okay. Fabio says we can use the H alpha filter
For the moon.
for the moon. Yes.
But okay, so what about the moons of
We could do this.
Mars?
The moons of Mars. We're not going to be able to see those probably, as they are very small.
What if like increase the exposure time to see if maybe we can see them?
I don't think that's going to work because the light reflecting off of Mars will just be so bright that it'll probably wash them out. And also the thing is, so Mars has two moons. The one is named Phobos, the other is named Deimos, and their names mean fear and something else. It's not loathing. I don't remember. One of them is fear, which is Phobos, I think. Yeah. But anyway, so Phobos orbits really, really, really close to Mars. I think it orbits only 6,000 kilometers up, basically, from the surface. So it's actually passing through parts of the extended atmosphere. So it'll be really close, so that would be even harder to see.
Okay.
Yeah.
And what will the other one?
Deimos orbits quite a bit further out. I don't remember its exact orbital radius. You could potentially like maybe discern it from Mars.
Oh no.
But it's
do like a 1 minute exposure, see what happens.
Oh, okay, fine.
Just maybe we can see them.
I don't know, man. They're pretty dim.
I mean, these telescopes are they're good telescopes.
They're pretty good. Okay, what do you want me to do? 1
minute.
1 minute?
Yeah, six.
Okay, let's see what
Let's
happens.
see what happens.
We're gonna do 60.001 seconds because it's too hard to change it.
Yeah.
Oh man, I should have. Oh, what did I click? I clicked the wrong thing. Thanks.
So
I should have worn 3 pants instead of just 2.
This is a problem with open houses during the winter.
I just didn't expect my legs to be this cold, but next time I'm just gonna wear my
This floor
ski
is
pants.
freezing.
Yeah, it is.
Like my shoes and my feet are freezing.
Ouch. No, there's so many things on my ears, man.
Yeah.
Okay.
Okay. 30 seconds left.
Where is it showing me? Oh, in the blue bar. Okay.
It's fine at 3 by 3. Try by 1.
Try 1 by 1. I don't even know what that means.
I mean,
oh, it's the binning.
It's the beginning here.
Well, don't do it yet. almost there.
I feel like we need like no meaning for. Thanks, Fabio. We did it. We missed that one. We're gonna need it for the moon.
What I need is like the advanced course on how to operate the telescopes because I'm still going off all the training from when I started.
Yeah.
Or
Let's go and begin it.
That looks nice. I'm gonna guess that little thing on the right is a star. I don't think.
No,
that's...
this is just a hot pixel.
Oh, what's the reading on it?
12. I mean, it's just one pixel. Well,
Yeah,
it's also
it's
dim.
one
It's
pixel.
okay. Wait, it's also dim. So
Okay.
so let's try not bin, and then maybe that's something.
Oh yeah, Fabio said we forgot to change the filter for Mars
Also,
because I think we're still in the O filter. We should try the R filter.
board. There you go. Red.
Yeah, there we go.
Move now.
We got a gap in the sky, it looks like. Up here. Might be able to see something interesting. Oh my gosh, my mask keeps falling off and it's driving me
Yeah,
crazy.
Hot pixel.
Okay, bummer. It just won't stay.
So there's a mission to go to the moons of Mars.
Yes, there is. What is it called again? I'm trying to remember. the name of it.
JAXA? No?
No, it's not JAXA. JAXA's not going there. JAXA's the Japanese Space Agency.
I thought that they were the ones who were going.
Oh wait, maybe they are. God,
Yeah.
I thought it was. Oh, I'm mixing it up. They are going, but the name of the mission I think is MMX, Mars Moons Explorer. X,
Oh.
not E.
Like
reasons.
you mean like NASA? Like NASA has a mission?
No. Yeah, it's JAXA. I think that's driving the mission. But the name of the mission is MMX,
Oh, okay.
Mars Moons Explorer.
This is something.
Could be. That would be Deimos if it's anything, or a star.
I think the star will be brighter at this exposure.
Probably.
This is 100% something.
Yeah.
Okay, so this is a moon.
All right. I didn't believe we could see it,
Okay,
but I was wrong.
Let's see if this thing has information on the moons.
Ooh, you have to go in pretty close.
No, it doesn't.
No. It resolves the picture of Mars, though. Yeah.
Okay,
Well,
I think we just discovered a moon of Mars.
we discovered it. We didn't know about it before, but we found it.
Oh, sorry.
Okay, let's save
There
the
you go.
picture because this is a momentous occasion.
Okay, this is already a good one. So where's the music? Yeah.
Oh, how do you do it? Yeah. Put it like on the desktop or something.
Seth.fit.
No, we're not calling it Seth.fit. What's that about? We discovered a moon. Deimos.
Yeah,
It's definitely Deimos.
Fabio confirm our discovery.
Fabio confirm. Hashtag confirm.
Yeah.
Wait, can we save it as not fits? I just want a basic layperson file. I guess we can't. All right, fine. I guess we'll do fits. So this. Hey Fabio, can we do this as like a JPG or a PNG? Like not a fit. I don't know how to do it. But for everyone else watching who is not an astronomer, FIT is just a special file type that stores image data that we use to do astronomical research and planetary science research, actually. But you have to use a certain software to get it to actually display as like a visual image. So if we save it as FIT, I won't be able to open it unless we have.
Do we have a Google Drive for this? Okay, let's see.
Oh yeah.
Open house. There you go.
Oh, there you go.
Yeah, I mean,
looks like it's
they're
just
all
fits.
fits. So.
Okay, that's fine.
Okay, so Deimos.
Yeah. But yeah, so it's hard to open these as an actual visual image unless you have the right software. And I don't know if we have DS9 on here and/or other softwares.
Yeah, I think we do have DS9.
We do have DS9?
Yeah.
Let's look for it. We do have it. Hooray! I mean, we don't need to. We can see the image right
we
here.
already have that one. Yeah, but
I was just
try other
explaining
contrast. Try other contrast.
You try it. I don't know what I'm doing.
Okay.
I'm really cold though. That's a nice shape.
Yeah, I think.
And for those of you watching, which apparently is mostly my family members, but possibly others as well, feel free to ask us questions in the chat or heckle us or whatever. That's cool too.
Oh, say
If you want to look at something like a favorite planet or whatever, you can ask us about it. Most of the planets are not up right now, but we can tell you if the one you want is.
I was gonna ask you, what can you tell us about the moons of Mars?
I told you most of what I know. The rest of what I know is mostly about how they are both very they're technically not interesting when you look at them in certain ranges. So if you look at them in the visual range, like with our eyes, of course that's interesting, right? Because, oh, cool, it's the moon. But if you look at it with infrared eyes, like an infrared, for those who don't remember, is like when something is hot, it emits this radiation. That's not a moon. But yeah, so if you look at these guys in the infrared, they're actually very boring because when we look at the actual like spectra, like what the light, like how much light we're getting from each different wavelength of the light, there's not a lot of features in the infrared. And this is very confusing because people don't really know why this is. They've been trying to compare them to other similar objects for a long time, like trying to figure out what does it mean for the composition. It might be the composition. I think more likely what's happening is it's probably space weathering. But
from Mars?
Partially from Mars, like on Phobos, because Phobos is going through the extended atmosphere, so it's going to experience more weathering. Deimos, harder to explain maybe. But basically, when you look at the Martian moons and then you look at other objects that are small and rocky in a solar system, like the asteroids, they don't look like anything else. So the Martian moons are kind of unique in that way.
But you know, I've heard a theory that the Martian moons are captured asteroids.
That is a popular theory. And there's also a theory that they were formed out of an impact with Mars. So
yeah, I know. I like that one better.
I like that one better too. So what are you pulling up?
I'm showing that the asteroid belt is close to Mars.
Yes. So this is why people think that they could be captured asteroids. So early in the solar system's history, things were not always so tightly organized like they are now. Planets were moving around, migrating. Especially Jupiter and Saturn may have undergone some pretty significant movements, like towards the sun, which would have scattered a lot of things around and just made a big old mess. So it's possible that in that time, maybe Mars was able to capture an asteroid from the asteroid belt, because as you see, the asteroid belt is there.
You see how close it is?
Yeah.
So maybe one of these guys. Yeah, of course.
Yeah, it's a cartoon.
It's a cartoon, but it's closer than the Earth is. Is that true? I think that's true.
Yeah, so Mars, so Earth, we can say the distance from the sun to Earth, we can call that 1 because, we're the most important thing, obviously. And then the distance from sun to Mars is 1.5, about. And then the asteroids are at about 2 to 4 times the sun to Earth distance. Okay, so we call it an astronomical unit. So Earth to sun, 1 AU. So Mars is 1.5 AU, asteroids like 2 to 4 AU.
Yeah, so there's this theory about one of these guys going in.
¿Es tu amigo?
I don't know, maybe. I think so, actually.
Asteroid belt. Yes, we are looking at the asteroid belt.
Okay, so.
I got a text message. Oh, I invited some of my friends to the stream as well, but their parents are visiting, so they're not able to. Maybe
yeah, so the I know the theory that it created that it was an impact, right?
Yeah. So for those who aren't familiar with Martian topography, Mars is kind of unique in that, we could just go to Google Mars. Check this out. You can go look at Mars on Google. So the interesting thing about Mars is that the whole northern hemisphere, basically everything above this middle line, is pretty low elevation. So on this scale, like blue-green is low, black is super low, but that's not really on here.
Zoom out a little bit.
Yeah, so I think it's.
So that you can see the sphere. I think you can probably zoom out to that point.
I don't know if you can. No, it just does this.
Oh, okay.
Okay, so this is about the extent of Mars. This is sort of the canonical view of Mars. So all this like southern hemisphere is pretty high elevation. It's like 3 to 9 above whatever we call the reference for Mars, and then the northern hemisphere is this big old basin. This is usually referred to as the Mars crustal dichotomy, meaning two different things right next to each other. But yes, so it's possible that whatever, if this crustal dichotomy was formed by an impact, it might have also formed the Martian moons out of Mars.
Yeah, like some, yeah. But there's also, I find it interesting that one of the moons formed so closer and the other one far away.
Yeah, yeah.
I think
So
that's very interesting.
it could have been formed that way. It could also be, if they were the captured asteroids, like the other theory says, it could be that it was just like caught in a particular orbit, and now that orbit is decaying and it's going to someday crash into Mars. That's also a possibility. But I am not a dynamicist, so I'm not totally clear on what's going to happen to Phobos in the future.
Yeah, I mean the Phobos-Deimos interaction may explain why maybe so one is going out and the other one is going in. That could be a thing.
Yes.
Yeah, like they were created more or less. Because what I'm thinking is that there's the Rocky, like the Roche limit, right?
Mm-hmm.
So you will have rings, or they will come apart.
Wait, so what's the Roche limit?
It's a little bit before. Okay, so the Roche limit. So when you have a body orbiting a planet or just a big massive object, there is a point
I can't do it.
very close to this object where the tidal forces cause on the satellite are so strong that it tears it apart, right?
Mhm.
So as you know, the moon and the moon and the Earth are pulling at each other. If the moon were closer, the force on the moon from the Earth will be so strong that it will actually tear it apart.
There's
Eh.
actually a really fun sci-fi novel about that. It starts out with one day the moon exploded for no reason, and then he just explores the implications for like 700 pages.
Like the moon came too close.
He doesn't even explain why it happened. He just sort of
Mhm.
goes with it as like a thought experiment. But yeah, if it came too close or like at a certain point, it would get ripped apart.
Yeah. So I know if you guys play Majora Mask. It's a Zelda game where the moon crashes into the planet. But in reality, that wouldn't happen because the moon will break apart when it's too close.
Well, what if
Anyway.
it came in really, really fast
I mean, I guess if
at
it's
a
not
weird angle?
if it's not orbiting, and I think you're right because that moon, it's always there. No, I have to remember because if it's not orbiting and it's just coming in a straight line, then
Yeah,
there's no Kepler and shear.
yeah, yeah.
You know?
If you just went, then
Yeah,
they would collide because they're basically just like two big, billiard balls.
but the moon does. I have to replay it again.
God, I hope no professors are on this call. They're gonna be like, wow, you would fail comps right now if you did it.
If I start talking about, well, we will fail comps because we can't solve the Majora Mask problem.
Yeah, that's how it would be. You must be able to play Zelda in order to do it.
Okay,
All right,
actually, let's Google Majora. I'm a little bit curious.
What? No, we're here to do astronomy.
I mean, Majora Mask moon.
Okay. And after this, we're gonna go to a new target.
Yeah.
What
Okay,
is
so,
this?
So image, that's the moon. Here's the place. We'll go to the image to see if we can see like the sky.
I actually never finished this one.
Yeah, that's too close. So we have to admit, and it's standing there, so that means that it has to be orbiting, like it has to be orbiting around.
Yeah, this is terrifying. I don't like this.
So in reality, that moon will be broken by the tidal forces of the Earth. That's the
if it was orbiting.
and then it will be the novel. Zelda will become the novel that she was talking about.
Yes. It is called Seven Eves by Neil Stevenson, I believe. It's definitely called Seven Eves. I think it's Neil Stevenson. Okay, so now what should we look at? Taking suggestions. Let's close our Mars picture. Zoom out a bit.
We got the moon. This is the first time I see Deimos in my life.
Yeah, I've never seen it before.
Yeah.
Is Saturn down? Saturn is just barely above the horizon, but it's looking pretty cloudy down there. So I don't know if we can get Saturn tonight.
Let's go to the moon.
Let's go to the regular moon, aka Luna. Where was it? It was in Capricorn.
There you go.
Yeah. There we go. Should we try a full sloop? Maybe we should try a short sloop.
Yeah, probably watching.
It's holding. Well, I mean, just to be safe.
Imagine
if we crash the telescope, then it's gonna take us like 20 minutes to restart.
Yeah, imagine if
stop the...
we decide to do the full slow,
Yeah.
and then it gets stuck.
Yeah,
and,
that would suck.
Fabio is gonna bring that up until I graduate.
Oh, it's still slowing. Whoops. Okay, one more time. There it goes.
I think you can jump.
From there to the moon?
Yeah.
Well,
It says all in as a right.
let's do M30. I don't even know what that is. Oh, I'm sorry, telescope. I'm trying. You might be able to get M30. What's the brightness of it? M30. What?
That movie. The problem
Helix Nebula.
with having that as a problem in an exam is that the persons need to have
Played Majora's
played
Mask.
Majora's Mask. But it's like in the game, the moon is coming closer and closer. And you're gonna have I think you can estimate how big the moon is.
Is it orbiting closer and closer, or is it just on a beam?
The orbit is decaying.
Okay.
Right, and at the end of the day, it crashes. But anyway, at the beginning, it's fairly far. I don't think that you would necessarily say it's on the road, but it's also very small. So.
Okay. I want to try and get the Helix Nebula, but I'm pretty sure it's not going to work. Magnitude 7. Oh, it's not going to work. We're going to try it anyway.
Well, it's just more exposure.
What filter should we use?
H alpha. It's a nebula. So nebulas have a lot of hydrogen.
Where are we already on H?
And hydrogen emit this line.
Okay, we're going to need okay, yeah, keep telling us about that, but I'm going to pick a time exposure. 30 seconds.
300.
No, it's bad. Okay.
Okay, go.
Okay, tell us about, what were you telling us about hydrogen alpha?
So nebulas are made out of hydrogen.
Fabio wants to know, is M13 up? And that's a great question. I know it is overhead in the summer, but it is full, and I am not sure. I think it's pretty low at this time.
Come on.
Slew, or not slew, but search.
Center. No, it's not out.
No, it's just over it's out of range of the telescope, but it is not over the horizon.
Okay,
oh, this is our picture. It's terrible.
I don't see anything.
Here, adjust the what you call it.
I think we took a picture of the moon because we took a picture of the clouds.
No, yeah, I was taking a picture of the Helix Nebula, but it was pointless.
Yeah.
Okay, as I expected, we're not going to get any deep space sky objects tonight, so let's go to the moon.
Look, the moon it's already very powerful. I think we watched the moon and we're done because look at it. We look at the clouds.
Oh, geez. Oh, they'll clear up in a sec. There's a lot of turbulence going on. M13, though, is one of my favorite objects, especially to show people in a telescope who've never seen it before, because it's like, I don't know, you see that in a telescope. I'll pull it up for you real quick on Google, but you see it in a telescope, and you're like, no way is that real? No way.
Where are you looking for?
Oh, Fabio says the moon might be close to the roof line. Oh, okay.
It's visible.
I was going to show them M13 for anyone who hasn't seen M13 because it's pretty fabulous. Oh no!
Show that.
Oh god, no.
It's very funny.
Okay, don't do.
Okay, let's just say that there is a model for a machine gun.
Yeah,
and a assault
I
rifle.
googled M13 and got a lot of guns, and what I wanted was this beautiful object. So that's fun.
Yeah.
Yeah, so you look at this as like a picture and you're like, yeah, it's a picture of like something in space. But when you see that in a telescope, it's like mind blown. I highly recommend it. If you ever go look through a telescope in summer, perhaps here with us at SBO, when life returns to normal, perhaps, hopefully in the future, or somewhere else, ask for M13. Yeah.
Yeah.
It just looks like a little jewel in the sky. It's fabulous. I love it so much. Okay. That's enough of that. What were we doing? We're looking at the moon.
At the moon.
And we're actually already there. So
H alpha.
we're going to take the H
It's
alpha.
already on.
It's already on. Okay, tell us about H alpha while I do this.
So this is a long story. So things are made out of atoms.
It's true.
It's true, right?
It is true.
In that's a nice picture.
Nice. That's pretty cool.
And atoms emit different colors of light.
Yeah.
Okay. Now H alpha is a color that hydrogen likes to emit a lot.
Can we see this color?
It's but H alpha is blue, ultraviolet, right?
It's ultraviolet. Yeah.
Yeah. So we can see H alpha because it's ultraviolet.
It's much bluer than blue. As in not visible.
Not visible.
It's not actually blue.
Yeah.
Yes, so go on.
Well, I think that's the whole story.
That's the whole story. Okay. Yeah, so it's it's in the UV, it's high energy emission. We are totally wrong. Oh, you're thinking of Lyman alpha. Haha.
This is Balmer alpha.
Yeah. Okay.
Yeah, okay, you're right.
Wait, Fabio's giving it to us in it's
In
probably
angstrom.
angstroms.
Yeah.
Angstroms is an evil unit. I hate angstroms.
So it's 10 to the minus 10 meters.
Yes.
Anyway, we were wrong. So things are made out of atoms. We got that one right. And atoms emit different colors. We got that one right. Hydrogen likes to emit the one we were thinking about, which is called Lyman alpha.
Yes.
And it also likes to emit H alpha, which is visible on the red. In the red.
In the red.
So it's a red light emitted by atom.
It's okay. I'll forgive you the angstroms. All right, we have another comment. There is a band. They are called M83. Is it a nice looking? That is a great question because I love M83. All right, is M83 a nice looking cluster or galaxy? M83, I don't know offhand, but we will Google for it.
Well,
It's probably not up. Or was that the one that was up?
let's see.
Where is it? No, that's in the southern hemisphere. Oh,
So-
it's a very nice galaxy. Okay, let's bring you a Google image.
So it is a galaxy. Well, you can only see it in the southern hemisphere, probably.
Is that right? I was guessing based on where
Based
it
on the
moved to.
name.
Yeah, well, zoom out a bit just to make sure. Where is it? Zoom out a little again. I'm all
I'm a little bit lost here.
discombobulated.
What is
Yeah,
this?
this is all.
Southern hemisphere.
This is the southern hemisphere.
Yeah.
You guys can't see where I'm pointing, but sort of on the right side.
This is the southern hemisphere. This green
Yes.
circle here.
Yes.
Yeah, because this is northern hemisphere.
Where's the other circle? Oh, the orange one.
Everything that is.
Oh no, I just couldn't see the circle.
Oh, yeah.
Okay. Yeah. Wait. So we're gonna bring up M83 real quick.
But it's you see, like it is though, like the orange does.
It overlaps a
It
little bit.
overlaps, so there are seasons where you can you
Yes.
can see M86, AM83.
Yes. It might be possible now, but I don't think it's possible with the range of the telescope that we have. Okay. So yes, M83 turns out to be a beautiful spiral galaxy, the southern pinwheel
Two-arm bar
cluster
spiral
galaxy.
galaxy. It looks like.
Huh?
2 arms and bar.
Yes.
Yeah.
Oh, that's the wrong glyph.
So you guys see, this is a good picture, that it looks like it is flat here. This is what we call a bar, a galactic bar. And then galaxies with bars tend to only have 2 arms. And these arms are caused by the gravity of the bar. And the bar is just stars moving like a rigid body because there's a particular density change from the center to going outside the galaxy. And there's
Did you take the galaxies class?
I'm taking the spiral arms seminar with Anne-Marie.
Oh, sick. That sounds cool. I didn't take galaxies. I wish I had.
Maybe I will at some point.
So
Do-
yes.
Do you guys do they actually do dynamics? Because it's like
I think they do. I think they use the Galactic Dynamics book by
mini intermediate.
yes.
Yeah.
Probably the viewers don't want to hear about it astronomy textbook because they're very long and very dense and full of math. But galaxies are super cool.
Okay, let's go back to the moon. What do you know about the
We're
moon?
going back to the moon. What do I know about the moon? Oh, I know very little about the moon. Where's our picture?
Does the moon have a closer and open again?
Huh?
Do this.
What are you doing?
Sorry, getting the
Oh.
picture back.
I
So,
thought it wasn't there. The moon.
So does it have an atmosphere?
The moon does not have an atmosphere. It is an airless rock, as they call it in some planetary circles. But it does have an interesting surface. Geologists, in particular, planetary geologists, are very interested in the surface. Do you know why they are interested in the surface?
Because they think that the amount of craters in the surface can tell us how old it is.
Yeah.
And then,
why would that be interesting?
So if
who cares how old this airless rock is? Oh, sorry.
So the idea is that the older a surface, the more craters it has. And this is true for the entire solar system. So if we know how old the moon is because we went there and we took some samples, and we know that it has 4 craters, say, then things that have 4 craters that are about the same size as the moon are probably also about the same age as the moon.
For big craters.
Yeah, for big craters. So we use the amount of craters in the moon to date everything else in the solar system. And then that puts huge error bars on.
Yeah.
On all the age estimates based on counting craters. It's not the best method to dating dating things.
Yeah, it is a method. So another cool way to date things is to look at like radioactive decay. But you can't do that without getting your hands on some sample that has had radioactive decay in the past and has now some residue product of whatever that decay process was. And we do have samples from the moon, but we haven't been back there since the 70s.
Since we got there.
Yeah.
Well, and there were other trips after Apollo 11, by the way.
Yeah, well, I'm saying 60s, 70s, but
it's
been a while.
No, but a lot of people think that we just went once.
Yeah, we went multiple times.
We went multiple times.
But yeah, so we collect a lot of samples there, but it's really hard to get samples from rocks in space. We can actually get samples from Mars if they fall to Earth. So there are folks who go down to Antarctica and go meteorite hunting because, like, you walk out in Antarctica and it's a ice field, and if you find like an unusual meteorite-looking rock, it's like, well, this fell from space.
Yeah.
But lacking samples, then you have to look at crater counting, which is something we can do with just a telescope and a computer and a human to do the counting. To do the counting.
You could,
you could train a computer, but humans are usually needed to make some interpretation. But the interesting thing, actually, an ongoing interesting debate about the moon and other objects, but mostly the moon, is that in one of the spots on the moon where some samples were taken, this one age kept coming up over and over and over again. And it was about 3.9 billion years ago. Like, all these rocks were dated at this age. And there were comparatively fewer dated before that in this particular large basin. So the thought was that, okay, there must have been this massive flux of tons of impactors coming into the moon 3.9 billion years ago and resurfacing the moon. And this became referred to as the late heavy bombardment. Late heavy bombardment.
Yeah.
So this sort of shapes the planetary geology community for a really long time, and still sort of does. But in recent years, people have been doing a lot of reanalyses and new analyses and models, and deciding, hey, maybe this actually didn't happen. There could have been different reasons for why we see a large number of rocks dated at this age. So it doesn't necessarily mean that there is suddenly a spike of impactors. It could have happened for other reasons. So this work is still ongoing, but that could change our understanding of the dynamics of the early solar system, how the planets got to where they are, what they were doing at that time. And there's also a similar related thing, is that some folks citation needed. Some people
Mm,
actually think some of the ages that we have for the lunar impact basins could be incorrect by
Yeah.
up to, I think, 1 billion years.
mhm.
So that would massively change the dates of
Yeah.
everything else in the solar system, if true.
And dynamically, the way the late heavy bombardment happened is that Jupiter and Saturn kind of moved around and made a bunch of rocks fly into the inner solar system.
Yeah. I think this is one theory. I think
Yeah.
one criticism of that theory is that most of the models for when Jupiter and Saturn would have been doing this moving around were early enough that they didn't quite line up with the supposed date of the late heavy bombardment. So there's been some
So
some work done in that area.
my take is that the late heavy bombardment wasn't late
It was early.
and it wasn't heavy.
Yeah.
Like it wasn't a spike, but it was kind of like the die-off of just planet accretion.
Yeah. So it's like, did we have a spike at 3.9, or instead did we have, some impacts happening right when the solar system was formed, and then it just sort of trailed off?
Exactly. So
Competing theories. So that's one of the hot topics in lunar science these days.
yeah.
So that's a very nice image of the moon, though. I don't know what we're looking at really.
I think this is it. I think we're looking at the moon. Yeah.
I mean,
Oh, you mean
I mean like what particular impact basin? It might be, because I don't know the scale of this. And my glasses are not.
I don't know. I have no idea. I didn't know they had names.
They do. Well, let's compare with Google, because thank God for Google, am I right? Okay.
Yeah.
Lunar basins. One of them is called the Sea of Serenity, or Serenitatis, or whatever.
So that's like the mareas.
Yeah.
Oh, that's nice.
This is not.
Okay, so
basis.
show that.
No,
No, this is great. I love the results of your search Google search.
I'm really bad at searching, apparently. I typed basis instead of basin, and now we have cartoons of lunar base.
So soon.
Soon, 2024.
Look, alien lunar base.
Oh yeah, that's the cool conspiracy
Over
theory.
here. I didn't know there was a. Okay. So,
Okay, what are we trying to do? We're trying to get the name of the basins. There we go. Yeah.
So this is the one we're seeing.
This one here?
Alphonsus. Let's see. Let's see this thing.
Why do you think that one?
It just looks like it.
It's just circles anyway. But there's two like right next to each other.
Okay, so it has to
I think
be
it's this.
Capricorn. Okay, there you go.
I think it's
this is those
the
two.
Sea of Serenity and the Sea of
But
Tranquility.
then this is
Oh wait, these little ones.
Alphonsus.
Where?
Like I mean, like this crater. Is this
That one.
crater? Yeah. And then you have.
That seems like too. This seems too close to be at that one.
Look, the moon is small.
It's not that small. I don't know. Oh gosh, this does look like Mare Tranquillitatis though, and then we've got Mare Serenitatis here. I am sorry if anyone on the stream speaks Latin. I do not. We could just do it in Spanish though. That's fine.
Let's see if the chat has any opinions about
Any
which
opinions?
crater is that crater.
Anyone want to weigh in on?
If
which
you think
crater?
that this crater is Alphonsus,
Vote now on your phones.
so here's Alphonsus. And I'm saying that this crater is this one.
It's possible. We can't see what's in between. If we could do that, we will maybe get more of a sense of where we are.
Yeah.
We have no opinions. We're gonna have to remain divided on this
Okay.
for the rest of the night. Whew, it's cold.
All right, I think it's time to call it.
It's time to call it.
Yeah, it's been more than
Okay.
an hour.
Yes, but we did start a little late, so we said we would go a little bit long. It's
Okay,
9:15 now. Does anyone have any more questions or things that you want us to look at?
What is oh, no, the lunar base. He's talking about the lunar bases.
Oh yeah.
This is some lag you have. I mean, I think everybody has the same lag. But I'm sorry, Fabio. Okay,
Yeah,
we're
it might be the cases. I don't know.
we are reading your comment at 9:13.
That's so so weird. It's not really that live then, is it?
But in your family, it looked like it was live-ish.
It was relatively live. I don't know.
It was doesn't.
It might vary with internet connectivity and whether people are on Wi-Fi or whatever. LOL. Yeah, okay.
think-
There's some lag. There's some lag involved here. Um,
I see him laughing of the alien. I don't know. It's impossible to know what I'm laughing.
I don't know. Yeah, so we'll hear for a few more minutes. We're taking suggestions and or requests.
Oh, and it's not bad. It's not a bad look. He just
I'm gonna take a look at the sky real quick to see if there's anything we
Yeah.
can see. Danielle will entertain you in the It's pretty cloudy.
Look, I think yeah, your cousin. This is your cousin Denise.
Yeah,
Uh,
it was the crater. I think she agrees that it's Alphonsus.
she agrees that yeah. So
All right, I guess it's 2 against 1. So
It's
this
2
crater
against
is
1.
now Alphonsus. Whether or not it's true, we have renamed it.
yes.
In other crater-related news, before we go, the Mars 2020 mission, Perseverance, is currently en route to Mars, and it is going to land in Jezero Crater, where there is an ancient river delta because water did once run on Mars. So super cool. Look it up. My advisor actually attracted me to study Mars by showing me a picture of Jezero Crater and telling me all about the cool data that was available. So keep a lookout for that. I don't remember when it's going to land, actually. I should really know that. Let me look it up real quick.
Somewhere in the next decade.
In the no, it'll be sooner than that. Mars isn't that far. It's not like Titan or anything. Although we are also going to Titan, which is super neat. Let me just look up Mars 2020 real quick. I should really know this as a Mars person. Okay, it's going to land in February 18th.
That's not, by the way, that's not a good name for a mission.
Perseverance. It's a great name.
2020 is Jinx.
Oh yeah. Well, this was like the code name before they named the mission. So the
mission is not 2020 anymore.
I mean, that's when it was launched.
It is Perseverance. And
Yeah.
Ingenuity.
So the rover is going to be Perseverance, and then I guess Ingenuity is the orbiter. Oh, the helicopter. I forgot they're doing a helicopter.
They're doing a helicopter.
Yes. I don't know what the orbiter is called. Maybe.
Why would you send in a helicopter?
Are they doing an orbiter at all? No, they're not. They're not doing an orbiter.
I guess they're
That's
probing
right.
the atmosphere or something like that. That's why they need the.
Well, it's a lander, and they're not doing an orbiter. And I know this because the mission that I am a part of, Maven, is going to probably help with that by doing like communications. Unless they, I don't know if they're doing. I don't think they have an orbiter. I think it's just the two. So yes. In February, look for new Mars rover in Jezero Crater. And I think we should probably wrap up here because it is very, very cold and I need to go get into my bed. But cool. Thanks for hanging out with us.
Yeah, thank you guys. We do this every other Friday, more or less. Well, next Friday we're gonna be here. I'm gonna be here next Friday at least with Kaya. No. Kaya sang now. I'm gonna be here. I don't know with whom yet, but see you next week.
Yes. It is next
Fabio,
week.
thanks for.
Yes. Next week we will do it, and then I think every 2 weeks.
And then after that, it's every 2 weeks. Yeah.
Okay. Cool. All right. Thanks for tuning in, everyone. Good night. How do we stop this thing?
Stop share.
Okay.
And how do you stop streaming?
Bye.
Live up there. Or I guess end
End
the
stream.
Zoom call. Oh, there you go.
Oh God.